Okay, hello everyone. I'll make a start now on these questions. So welcome to the second method stream, and today we'll just be going through a few questions that were submitted. Um, so we'll start. First of all, there's three multiple choice questions, and they're all from the 2018 exam too, and these three are pretty hard conceptually. Well, I think question 19 is okay, but 20 and 18 are pretty hard. So we'll get started now. So for the first question, just have a read. You have two functions with unknowns, and then it gives you this statement here where it's saying which of the following is false for f of x is greater than g of x in the interval 0, 1, and g of x is greater than f of x in the interval 1 to infinity. So straight off the bat, it's you have these two functions with unknown exponentials. It's going to be very hard to visualize. So the strategy I would suggest using is just substitution. You'd sub in values for each of these, and it's going to take a while, but I think that's the only viable strategy because, again, with these unknowns, it's very hard to visualize. So I'll just start now. I need a graph. Okay, so let's say for option A, q is greater than n and p is equal to m. So let's just let q equal to 3 and n equals 2 because q is greater than n. And then so your functions would be x, and then p is equal to m. We'll let p and m both equal to 1. So your function f is x to the 1 over 3, and your function g is x to the 1 over 2. And then, so you have these two, and then you're trying to find if this is true for it. So for where f of x is greater than g of x over this interval, and where the opposite is true for this interval. So to do that, you'd graph, and since this is exam 2, you have a calculator. So x to the 1 on 3, and then x to the 1 on 2. Okay, and you can see that it is true for let me zoom in real quick. And you can see that it is true for this. So your f of x is the blue one, and the red one is the red one is g of x. And then if I just go analyze and find the intersection, and that's 1, 1, and you can see that from 0 to 1, from 0 to 1, f of x is greater than g of x, and from 1 to infinity, g of x is greater than f of x. So that's true for A, and then I think it's going to take, well, in the interest of time, I'm just going to tell you the answer. The answer is E. This is false, but the way you get there is easy. So after doing that one, you just keep subbing in different values for all of these until you find one that doesn't make sense. So the answer is E, and I hope that cleared things up. And also, I think one of the hard things about this question is understanding what it's saying. So make sure that you know what this notation is. So the x such that f of x is greater than g of x for the interval 0, 1, and g of x is greater than f of x for the interval 1 to infinity. So there's that. Moving on to the second question. Okay. Question 19, also from the 2018 exam too. So you have two functions here, and it's basically asking you to find the area between this. And this is like a very common style of question you'll see in the multiple choice section for the exam. And the way I suggest you doing it is because they'll give you 5 options of like different expressions for the area. And then to make sure you don't make a mistake, like to guarantee that you get the mark, because I think this is a pretty easy mark to get, just go through one by one down the list. So just get started now. So straight away A will not be correct because you have these two functions that go above and below each other. So you can't just lump them all together in the interval 3, 0. So we can cross function A off straight away. And then looking at B, B also looks to be incorrect because it's saying that from the interval 3 to 5 on 3, sine pi x minus cos pi x on 2 times by 2. Obviously, it doesn't account for these bits, so B is incorrect as well. Let me just look at what the functions are. Okay, so that one's cos and that one's sine. Okay, and then looking at C, so we have 1/3 to 0, cos minus sine. Okay, so this bit's correct. And then this bit, you have cos pi x minus sine pi x. So here cos is actually below sine of x, but it's made it negative, so this bit is also correct because remember when you're trying to find the area between two graphs, you subtract the bottom one from the top one, but in this one cos is below, but it's made it negative, so this does equate. And of course these two areas are symmetrical, so he times it by 2. And then this last bit, 3 to the 5 on 3, so from here to here, and then it's saying cos minus sine pi. So again, it's done the thing where it's kind of reversed them, but he's made it negative, so it is correct as well. So usually it'd be sine because it's above minus cos, but in this case cos minus sine, but it's negative, so this is also correct. So the answer is C. So you can take away from that, for these questions where it asks you to find the area, the shaded area for like two graphs, just go down the list and keep checking each integral off. Just tick every integral off. Okay. And question 20. I looked at this before and it's quite a hard question to visualize as well, I think. So we'll make a start on it. So first of all, you get the piece of information that median of f is at 0 and the gradient is 4. So the median doesn't really matter because the median is the same for both. And we'll just focus on this. So f dash 0 is equal to 4. That's saying that the gradient at x is equal to 0 is equal to 4. So if we draw like just a little thing. So let's just pretend that that's the section of graph and the gradient is 4 there. And then for g of 0, the gradient is negative 1 at 0. So g would be like that. And then you'd have to find a transformation to make this turn into that. And I think the best way to do this is to try and visualize. So remember, from to go here to go from here, you can either reflect in x and reflect in y, and so you can reflect in x or y, but then you're probably wondering then which one would I choose, because you can reflect in x and y to get this. But since it gives you the piece of information that it's a probability density function, you can't reflect it in the x-axis, because let's see, if you reflected this in the x-axis, like sure you get this gradient that's also negative, but you also go into the negative y-axis, and since it's a probability density function, you can't have negative probability, so you can't reflect in the x-axis, so that only leaves us with reflect in the y-axis. And of course when you're writing it out as like equation form, like you know how that's a dilation of factor 2 from the y, same thing applies. So when you reflect in the y-axis, you're doing it to x, so straight away we can already rule out all of these ones because those aren't negative. Remember, when you're reflecting in y, you need to have negative x, so you're going to be either this one or this one. So once we do that, so I'll just draw the new one. So you reflected in the y and now it's negative 4, and now you need to make the function, I like to think of this as the function shallower, so it's not as steep, to get this gradient of negative 1. And if you're thinking about what a dilation of, like what exactly is a dilation of factor 2 from the y-axis, so let's just go through this one first. So if you think about it, if you just do this dilation, 2 of x, I'll just give you the example of a normal parabola, x squared. So if you do a dilation of factor 2 to x squared, it'll make it narrower. Or you can think of it as it'll make the gradient steeper, because since you made it narrower for every x coordinate, you're going to increase it by way more by the same rise over run. So since you've made it steeper in this case, we can rule out, because you're trying to make it shallower, so rule this out. But we can also check the half y, and if you think about exactly what a half y does, so again I'll do it here. So that's x squared, and then if you dilate by a factor of half from the x-axis, your okay, so y on 2 is equal to x squared. So again, you're making it narrower as well. So we can probably rule out, because you're making it steeper both times, you can rule out A and choose D. Okay, I'll just see if there's any questions for this. Okay, so everything's good. And I'm still iconic. It's just my Twitch name is Quantum. I'll change it back. Okay, so multiple choice done. Now we'll move on to some of the other extended response questions. So okay, question 2. This is from the 2020 exam. Have a read. So you have the north bank is F1, the south bank is F2. Okay, so starting from question E, let me just zoom out a bit so I can see everything. Okay, starting from question E, a horizontal line is drawn through point P. The section of the river that is south is declared as a so let me just do that. Okay, and all of this is a no swim zone, and it's telling you to find the area of this. So it might look like, it might come across as a simple question because, oh, it's just u minus 1 equal from another, but you need to account for these areas on the sides, because if you think about it, if you take away f1 of x, like if you take away f1 of x in this interval from f2 of x, then you're still leaving in this area. So you need to find a way to find these two sides. And I think once you visualize it, it's pretty easy. So like you can draw two rectangles and then just minus, and then you can just minus this area from the two rectangles. So we'll just do that now. So first of all, you got to find the terminals, and the terminals would be, so the y coordinate of P is 30, so you just do 30 is equal to f2 of x, and let me just define that real quick. I'll call f2 of x g of x because you can't like do f. Can you do f2 of x on the calculator? No. Okay, I'll just call it g of x. Be safe. Over 100 plus 30. Okay, and then you can solve 30 is equal to g of x for x. Oh, okay, I need to specify my domain. What is it? So 50 smaller than x, just smaller than 150. Oh, okay, I'll make that larger. Let's make it. Where's my shit at? Okay, smaller than or equal to x, just smaller than 200. Why not? Okay, and then you get your where's my thing? Okay, and then you get your terminals, which are to 50 and 150. Again, just visualizing exactly what that means. So if I drew that line across to signify the no swimming area, then I'd get the terminals for the integral from 50 to 150. And okay, that's all well and good. And then okay, so we have 50 to 150, but again, we need to consider that you need to leave out this area above. So we'll take these two, because from, okay, it's probably a bit confusing. I'll erase everything. Okay. Okay, so because you're leaving out these two rectangles, you can just find the area here from these two terminals. And to do that, instead of letting 30 equal to f2 of x, you let 30 equal to x1 of x. Oh, f1 of x, sorry. Because it intersects with the top bank here. And where it intersects with the top bank, you can find this area. So I'll just define f1 of x. Okay, and then I'll calculate the actual area of it. So menu 4.3. Oh crap, I need to solve first. Okay, solve f of x equal to 30 x. Okay, I need to do my domain. Say 0 smallness 200. Okay, And so I'll show what exactly that means on this. So on this graph, that means that point is 200 on 3, and that point is 400 on 3. Okay, and then calculating the area of that bit, just go 400 on 3, 200 on 3, the top function minus the bottom function. Okay, and that is equal to, should I on a calculator? Okay, and then that bit is equal to 2000 on 3. So you have the area of that bit, but you're still not done because you need to find these two bits. And then, so drawing these rectangles helps a lot. And also just try and visualize exactly like what you're doing with the integrals. So, you know, you have these rectangles and you're trying to find this. So the area would be the area of the rectangle minus the area of, or it'd be the area of the rectangle minus this bit. You know, so I'll draw it out here. So you have this, you have this rectangle, and then like let's just pretend this is the bit of the river. And to find this area, it's like finding the area of the entire rectangle minus the bit that's just below it. So you're left with this bit. If the drawing's pretty bad, but you get the picture. So first of all, finding the area of the rectangle. Well, we know the base because we found these two intersection points. So the base is just 200 on 3 minus, minus 50. So it's 50 on 3, the base. Area is equal to, 50 on 3 times by the height, and we know the height because point P is 50 to 30, so times 30. And then minus that thing that we specified. And then this area, of course, it's just the area under the graph of f2 of x. So minus the integral from the same terminals. 200 on 3, 50 f2 of x. Okay, and doing that, it's, so let me just, so it's 500 minus 500 minus the integral of 50 to 200 on 3 f2 of x. Oh shit, my bad. Okay, sorry guys, I'm kind of shit at using this on the computer. Okay, 50 200 on 3 g of x d of x. Okay, and you get that, which is, oh, okay, it shouldn't be negative. I think I've done something wrong. Okay, it shouldn't be negative, so fuck, I think I've done something wrong. Let me just make sure I did those right. Okay, so that's 30. 20 cos pi x over 100 plus 30. Okay, wait, let me just try this again. Times by 30. 500 minusing the integral of, I'll just check the terminals. So okay, I'll just check the terminals again. So solve 30 is equal to g of x, x. Need to do my domain. Okay, 50 and 150. Okay, so I have the outermost ones right. 203 and 400. Okay, so the terminals are right. So let me just do this whole thing again. Integral 4, 3, 50, 200, on 3, g of x, d of x. Let's get that. 500 minus that. Okay, and it's positive now. I don't know what happened then, but okay, that's your actual area. But remember, you're still not done yet because you remember the scope of the question. So you just found the bit for this one. So to get the bit of both of them, you times it by 2. Oopsies. Times by 2. So you get 170.5. And then the total area is just the area you calculated before plus the thing you just did. And then do that on the calculator. It asks for it in decimals. So 837.2 to the nearest square meter is 837. Okay. Now moving on to question F. Scientists observe that the north bank of the river is changing over time. It is moving further north. The rule K F1 of x. Okay, so that's the north bank. And then for which the distance north across the river for all parts of the river is strictly less than 20 meters. So straight away, you want to try and make an equation. Whenever you see something like a less than, more than, or equal to, you always want to make an equation. So now you just got to figure out which equation exactly you need to use. So here it asks for the distance north across the river. And then if you think about it, the functions f1 of x and f2 of x themselves give us the y coordinate. And the y coordinate is just, you know, how north a thing is, like the coordinate that corresponds to north. So the distance, like the straight line distance north exactly is just y2 minus y1, or f1 of x minus f2 of x. So you have that equation already, but then you need to consider that they've dilated by k. So your equation for the distance across the north, or your equation for the distance north is just k f1 of x minus f2 of x. And then let me just see what that exactly is. K times f of x is that minus g of x. Okay, and then that is your equation for the, oh shit, okay, yeah, that is. So that's your equation for the distance north. Should write that out. Cos plus 40k minus 30. So now you have that, and then I think it's pretty easy. You just find where that's less than 20. So on the calculator, let me just, so find where that's less than 20. So if you move the 20 over, it'd be minus 10 is less than 0, and then you can see cos times x over 100 plus 4k minus 10. So that's your new equation. And then let's just find where that equals 0. So I'll just solve directly then. Solve. Okay, that didn't work. Okay, let's just solve where that equals to 0. Okay. That should be x. Okay, maybe not. Okay, so let me just think about this. Okay, so that's the distance. And you're trying to find where that's less than 20. Okay. Maybe, okay. Because, okay, so I've solved for k and it's given me where k is equal to 5 to cos pi x. Okay, well, I'm not going to write that out, but you can see it on my calculator. So it's giving me k is equal to that. So maybe if I sub in an x value, let's just say x is equal to 1. 1.25. Okay. Sorry guys. I did this question before and then I thought it was pretty easy, so I'm just gonna redo it, but I seem to have forgotten how to do it. But this is your equation for the distance. So I hope you'll see how you're doing it. Like, this is your equation for the distance, and then it's just saying that where the distance is less than 20. Like, for what values of k will the distance be less than 20? So, maybe did I answer the equations right? Minus g of x. Yeah, you get that, and then I'm gonna look at my exam that I did and see what I did. Oh, okay. So, okay, that makes so much sense. Okay, so because you're trying to find this such that it's always less than 20, it's like saying that the max value will be less than 20, and we all know that to find the maximum value, you need to derive. So I'll just derive that real quick. So, oh shit. Okay, d dx k times f of x minus g of x, and you get that. Wait, okay, never mind, I need to actually do this. Okay, so you get that, and then that's your derivative function, and just reminding you guys we're finding the max value, so let that solve where that equals 0 for x. Oh, let me specify a domain. Just say, okay, that's too big. Okay. Oh my god, okay. Well, we won't do the domain because this is easy. So, your maximum is at x is equal to 100. And if you sub in x is equal to 100 to your distance equation, you'll find, okay, so 20k or okay. Wait, is this? So your maximum occurs at 100. And if I sub in 100 to my equation, okay, wait, let me just write out my equations again. Okay, yeah, so you get 20k times cos pi, which is just 20k times cos pi is just -1 plus 1, so that's just 20k, and then g of x is -20 plus 10. Okay, so that is right, so it's negative 20k minus 10 smaller than 20, negative 20k smaller than 30, k is smaller than, okay, that's not right. Sorry guys, I think I've done something wrong here. No, Angus, it's not incorrect. Okay guys, so for when it says strictly, for a question like this where it says strictly less than, that it is what it is. Like, it's less than. It's not less than or equal to. But when you say strictly decreasing, that only applies to graphs. So like when it says something strictly decreasing or strictly increasing, you have to be inclusive. But for this one, it doesn't matter. Fuck. Okay, I probably confused you guys a lot, so I'll just rewind. What it was asking for was the distance north across the river, and to find that distance is just the function 1 minus function 2, because you're finding the y distance between the two, and then you multiply it by k, so you get this, and then you get this equation, which is the distance, and then obviously, and then it says where the distance is less than 20. So you can't just solve this usually. So if you think about it, when a distance is always less than 20, the maximum value has to be less than 20. So right now I'm just deriving it. I'll just derive it again. Menu for 1. 20k minus 20 times cos pi x over 100 plus 40k minus 30. Okay, and you get that, and then solve for that equals 0 to find the maximum. So you get 100 and or k is equal to 1. Okay, so I think it was a domain error then, because x equal to 100 wasn't right. So if it was a domain error, then even in a real exam, you guys can always try again. So if you subbed in 1 for n, let's say, and it didn't work, I'll sub in 2 now. So x is equal to 200 is where the maximum occurs. And then if I sub in 200 to my equation here, I'll end up with 20k minus 20 times by 1, because cos 2 pi is just 1, times by 1 plus 40k minus 30. Okay, so you end up with 20k minus 20 plus 40k minus 30. That's the equation. And all of that is less than 20. So 60k minus 50k. Okay, this looks more right. So 60k minus 50k. Oh, that's not k, that's just 50. So 60k minus 50 is less than 20. And 60k is less than 70. So k is less than 7 on 6. For find the values, yeah, so those are the values of k for which it's less than 20. But of course it said that k is greater than or equal to 1, so make sure you finish off with 1 is less than or equal to k, which is less than 7 on 6. Okay, so sorry I got a bit confused there, guys, but so you get the idea. Find the maximum to find, and this applies to other questions as well. So you can find the maximum if it asks you to find for what values it's always less than a specific value. So that's the answer. Now moving on to another question. I'm not sure which exam this is from, but you just have a solve equation of theta. So question A, state all possible values of tan theta. So this is just asking like for what values of theta does it not exist, right? And remember, if you like graph it like this, it has an asymptote at pi on 2, negative pi on 2. But in this case it says all possible values, so you need to consider, like, because the graph repeats, like, you need to consider the asymptotes over here, and there should be a general equation for the asymptotes. So let's just figure it out now. So there's an asymptote at pi on 2, and then there will be an asymptote at 3 pi on 2. So it's looking like the equation to find the asymptotes is just x is equal to because it's always odd, so plus or minus 2n plus 1 pi on 2. And I've done this because this is signifying that it's an odd number, or an odd integer in front of pi, and then this is the plus or minus because you can go negative and positive. So therefore, because those are all the asymptotes where theta doesn't exist, so therefore theta is equal to all real numbers except for, oh, okay, it's bad drawing, except for plus or minus 2 and plus 1 pi on 2. I think that's what the question is asking you. Okay, no questions for that. Okay, and now moving on. Hence, find all possible solutions for tan theta minus 1 sine theta. Okay, so this might look a bit confusing, but like once you realize Vikas tricks, I think it's pretty easy. So if you notice this looks quite familiar to this. And, let's just say you expanded this, you times them together, that'd be sine squared theta. Oh yeah, I'm just multiplying these two together right now, the ones at the top, guys. So sine squared theta plus root 3 minus root 3, so they cancel out. Minus 3 cos squared theta equals 0. Okay, so this equation, once you do that, it's exactly the same as this one. And then once you do that, you have these three terms with brackets that all equal 0. You can use null factor law. So I'll just go do that now. So tan theta is equal to 1. Theta is equal to theta, and then here you have your domain 0 small to pi small. So theta is equal to pi on 4 here. Make sure you know your exact values. And then the next one is sine theta is equal to root 3 cos theta. So that means tan theta is equal to root 3. I just divided by cos. So theta is equal to pi on 3, again with the exact values. And the next one is sine theta is equal to negative root 3 cos theta. Tan theta is equal to negative root 3. And then I'm just going to draw a unit circle. So you have here, that's pi on 3, root 3. And then you remember the symmetry, how this is pi minus pi on 3, and then that would be negative root 3. So theta is equal to 2 pi on 3. And then theta is equal to pi on 4, pi on 3, 2 pi on 3. Okay. Are there any questions for that bit? When a question says hence, does it mean you have to use info from the question before? Yeah, it does, but this is quite broad, so it's just saying that make sure these are asymptotes, right? State all possible values of tan theta. So like let's say you got like tan theta is equal to pi on 2, then you wouldn't use that because you know from before that pi on 2 is an asymptote. So that's to use hence from here. But for other questions, the hence might be a bit more obvious. So I'm just gonna hang on. My handwriting's pretty bad. I'm just gonna make this a bit better. Theta is equal to all real numbers. What the? Okay, all real numbers except for on 2. Okay. Okay. Okay, moving on to this question. I'm not sure. Oh, this is okay. I think this is a 2017 exam 1. Okay, moving on to this question. The edges of the right angled triangle ABC are the line segments AC and BC, which are tangent to. Okay, so theta is 45, it says. And then, since we know that the angles in a triangle are up to 180, this is also 45 because above we have a 90-degree angle. So find the equation of the line through B and C. So it's just saying find the equation of this line, which is tangent to the graph here. And we have all the pieces of information we need to know because we have the angle here. So therefore, we can say that the gradient will be tan 45. Which is equal to 1. But remember, within the bounds of the question, you can clearly see that the graph is negative, so it'll be negative 1. So that means the gradient is negative 1. And then you're just finding the point on the graph where the gradient is negative 1, because since it's tangent to the graph here with a gradient of negative 1, then at this point the graph must also have a gradient of negative 1. And to find that, you derive. So we can't use a calculator for this one. I'll just do it by hand. dy dx is equal to. So that's x to the 3 on 2. So dy dx is equal to half x to the negative half minus 3 on 2 x to the half, which is equal to 1 over 2 root x minus 3 root x on 2. Okay. So that's your derivative, and then you just solve for that equals negative 1. So is equal to negative 1. So how am I going to do this? Times everything by 2. Is equal to negative 2 times everything by root x. 1 minus 3x is equal to negative 2 root x. And then notice we have a quadratic equation. So I'll move into one side. 3x minus 2 root x minus 1 is equal to 0. So here we can consider this a quadratic equation because if you think about it, x is square root of x squared. So let's just say let a equals to root x. Then we can say that 3a squared minus 2a minus 1 is equal to 0. Okay, and then solving that for a, let me just see. Something that times is the negative 3 and adds negative 2, negative 3 and 1. So plus a minus 1 is equal to 0. And here I just did grouping. If you guys need me to explain, just ask. Okay, we're good. So I end up with 3a plus 1, a minus 1 is equal to 0, a is equal to negative 1 on 3, and 1. And of course, remember that we let square root of x equal to a, so square root of x equal to negative 3, 1. And then if we square everything, x is equal to 1 over 9, and x is equal to 1. Okay, so that means that this here is 1 over 9, and this here is 1. And although it might not look like it, that's 1. So now we find out the coordinate where it intersects. So then now we just need to find the y coordinate. So sub in for x, y is equal to root 1, 1 minus 1, y is equal to 0. Okay, that means that our gradient, or let me just rub stuff out. So y minus y1 is equal to mx minus x1. So y was 0, so y is equal to, and x1 was 1. So y is equal to negative 1, x minus 1, y is equal to negative x plus 1. That's the equation for the gradient for BC. So there you have it. Okay. Now find the coordinates of C when theta is equal to 45. So we can keep the same stuff. Find the coordinates of C. So straight away, you're thinking, okay, I need 2 equations because, if I'm trying to find the intersection, which this is, you're going to need 2 equations. So you already have BC, so you'd find the equation for AC. So let L1 is equal to AC. So L1 is equal to 1 over 9. And then you need a coordinate. So, oh no, sorry, not 1 over 9. MAC is equal to 1, as we said earlier. And the coordinate of x is equal to 1 on 9. Okay, and then you can sub in for y. Square root 1 on 9, 1 minus 1 on 9. And that's 1 over 3 times 8 over 9. So the y coordinate is 8 over 27. Okay, and then putting it all into an equation. So y minus 8 on 27 is equal to m, which is 1, x minus 1 on 9. So y is equal to x minus 1 on 9 plus 8 on 27. I'm trying to do this in my head. Whatever. That's like 3 on 27. So it equals to, y is equal to x plus 5 on 27. Oh, that should be a 5. Okay. So that's the equation for AC. And then from before, your equation for BC, what was it? Let me see. Negative x plus 1. Okay. So it's easy now. So you just let those equate. So negative x plus 1 2x is equal to 22 on 27. X is equal to 11 on 27. Okay, so that's the x coordinate of point of intersection. And now you need to find the y, and you just sub it in again. I'll sub it into that one because it's easier. So y is equal to negative 11 on 27. Oh, fuck. Plus 1. Y is equal to 16 on 27. So that means that C is equal to 11 on 27 and 16 on 27. Okay. So that was a lot, so I'll recap. So for this one, I determined the gradient because when it gives you the angle, you can always use tan to find the gradient. And also for this one, it asked me to find the coordinates, so I realized I needed 2 equations to find the intersection. So that is all well and good. So that was 4 marks, and I think that's quite generous. So this should be an easy 4 marks. So that's good. My last exam. Okay, my microphone is spazzing out. My last exam. Okay, my microphone's doing some weird shit. My last exam is 17th, Andy. Okay, I'll move on. Okay, this is quite an infamous question, I think, because of all the stupid wording. So this is 2020 exam 2 question 3F. So just have a read, and then like you'll see what I mean. So like from the wording, it's quite hard to like really deduce what they're asking. So okay. Okay, so once you guys have read, I will explain what exactly it is they mean. So, an analyst from the government believes that the rival transport company's claim is only true for deliveries made. Oh, and also make sure you read this bit. Fuck. Make sure you read this bit above. Okay. So, for deliveries made after 4 p.m., the analyst believes that the probability of delivery arriving on time or earlier is X. So, it wants us to set out a couple of statements, right? So, from here, I'll just tell you what it is. It's asking for given probability because it's saying that probability that something is on time. We'll call something that's on time T. T, given that it's after 4 p.m., is equal to X. It's a really bad X. I'm going to rub it out. Okay, so there's statement 1. And again, that's just like, you need to be able to interpret that. If you can't do that, then it's impossible to do the question. And, from the wording, for deliveries made after 4, so given it's after 4 p.m., the probability of it arriving on time, which I call T, is X. Is that clear? Okay, no questions. Okay, good. And then the next statement, PR is this, right? Because it said that here it says that it's 0.85 for it to arrive on time, and then the analyst here says it's true for deliveries made before. So you can say that probability that it's given that it's before PM, the chance of being on time is 0.85. Okay, so there's that. And then if you keep reading, you see this bit was the actual question. Find the minimum and maximum values of y. So you know that at the end of the question you're trying to find an equation because with an equation you can map out the min and max values. So how are we going to get to an equation here? Well, if you remember the given probability formula, that I'll just do it for x first. PR, T, and after 4 p.m. over PR 4 p.m. is equal to x. And it says here that the probability that the delivery is made after 4 p.m. is y. So we can say that PRT is this is equal to x times y. So there's the first equation. And then the second equation, probability t given its blah is 0.85. Second equation, let's just write it out. PRT and this is over probability that it's smaller than 4, so it's 1 minus y, because we know that when two opposite events add together, it equals 1, so 1 minus y is equal to 0.85. So that means that probability t smaller than 4 p.m. is equal to 0.85 minus 0.85. What the hell? 0.85y. Okay. Is that confusing anyone? Oh, okay. Where did y come from? So, I got the y from here. So it told me that the probability that a delivery is made after 4 p.m. is y. And then when I wrote out my given probability formula, it's here. So, and 4 p.m. And it's over this thing. So it's over 4 p.m. And that's where the y comes from. The probability that something is after 4 p.m. is y. So I subbed in y there. If that's clear. Okay, so I end up with these two equations. So this one and this one. And, you know, I've largely eliminated all the probability nonsense. But, oh my god. Sorry. Okay, so I've largely eliminated all the probability stuff. But I'm still left with these two things. And then, in order to find a full equation, you need to find a way to get rid of these. And I think the best way to do that is draw out a Carnal table to see exactly what these things mean. So let's just draw it out really quickly. Okay, t, not t, greater than 4, less than 4. So from the question, it gave us that greater than 4 is y. And we don't need to fill out the entire thing because we just need to know these two, and so focus on these two columns. And we know that the overall probability that it arrives, look, and then here's another key piece. So, oh shit. So it says that the overall probability is 0.75 that it arrives from time. So we can say that for our t section, this is 0.75. And then, so we got these things. So PRT and smaller than 4 p.m. is 0.85 minus 0.85 y. And then we also have this, which is x times y. That, and then we can make an equation, right? Because we know that xy plus 0.85 minus 0.85y is equal to 0.75. So here we go. X. My pen is freaking out. Okay. X, y plus 0.85 minus 0.85y is equal to 0.75, and then we just need to rearrange for y. So I'm just going to do that now. Xy minus 0.85y is equal to negative 0.1 y x. Fuck. Okay. Y x minus 0.85. I took out y as a common factor. Then I get this equation. Okay, so now you have your equation for y, and from that you can find the min and max. So let's just graph it to see what it looks like. Delete this one and delete this one. So our new one is negative 0.1 over x minus 0.85. Okay, so you get this, and then you're probably thinking to yourself, well, this doesn't have a min and maximum, so the question's wrong. But we need to use another key piece of information from the question, and that's 0.3 is smaller than or equal to x, which is smaller than or equal to 0.7. So it's basically given you the domain of the thing, so the bounds of the thing, And then from that, you just sub in those bounds to find the min and max y value. So if I go to my calculator, if I sub in x is equal to 0.3, y is equal to negative 0.1 over 0.3 minus 0.5. Okay, so there's my minimum value number 1. Y min is equal to 0.18. How many decimal points was this to? Okay, so I need to convert to exact values because he didn't do it in decimal. So y is equal to negative 1 on 10 divided by 3 on 10 minus, what's this, 17 on 20. Okay, so there's one. Y min is equal to 2 over 11. And then y max, I sub in the other one, which is 0.7. So y is equal to negative 0.1, or negative 1 on 10 over 7 on 10 minus 17 on 20, and that's 2 on 3s. So those are your answers. The minimum value of y is 2 on 11, and the maximum value of y is 2 on 3. Is that clear for everyone? So if you want to make it look like, how do you rearrange? Oh god. Okay, so how do you rearrange on CAS? So usually, okay, but let's just say you get this. Alice, you already know this. Why are you asking me? Okay. So when you want to rearrange for x, like let's say you get this equation. When you want to rearrange for x, you can just say solve for x is equal to, or solve for y is equal to x squared plus 2x plus 1 in terms of x, comma x, and then it'll give you it in terms of x. So there's that. But for this question is pretty easy to rearrange, so I'd just say do it by hand to be safe. And I think just using the calculator for that would just complicate it. Okay, so done that. Mitch, so if you want to make it look like y is equal to, you solve. Yeah, in a sense, but for this one, again, do it by hand because it's a lot clearer. So that question was quite hard just for 2 marks. So I think it wouldn't really matter if you drop these because I think it, like, well, what's the percentage of this? Like 3% of people probably would have gotten this. So quite a hard question. So don't worry if you don't get it. But remember, the key is interpreting the question. And just remember, if nothing makes sense, just think about given probability. So here I got 2 statements with given probability, and then from there I broadened everything. I did the table to make the equation, and there. So I don't think it's worth 2 marks. I think it's worth way more, like 4 marks. Okay. And again, I'll upload this to YouTube, so if you guys don't understand, you can rewatch it and maybe glean some new info for that. Okay, moving on. 2020 exam 2, question 4. Just read. That's the graph. 2 line segments. Okay, let's just go straight to the question. Wait, I'll write the equation. So the equation is 2x e to the 1 minus x squared. Yep. So the first line segment connects that to that, where that's n. Okay, so find the equation. So I think this is starting off pretty simple. So the gradient, first of all, we need the gradient. That's just fn minus f0 over n. And if you just do that on the calculator, we just define everything. F of x is equal to 2 times x times, I need the legit e. Okay, got it. 1 minus x squared. Okay, and then I did fn minus f0 over n. And that's the gradient of the line segment. So e. And then I need the coordinates, and it gives you the coordinates, y minus n and f of n. We just to see what f of n is. So the equation to find my equation is y minus. Oh, I could just use 0. 0 would be much easier, wouldn't it? So y is equal to 2e 1 minus n squared x. So there's equation 1. And then equation 2, this one is n f of n and 3 f. Okay, so again, doing the same thing. Over 3 minus n. Oh, what the hell is going on? Just write that out again. Okay, fn minus f3 over n minus 3. So that's the gradient. Do that on the calculator. Whoa. Okay, so that's the gradient. It's looking very complicated. But don't worry, that is the right answer. Oh wait, sorry, it should be 3 over n. 3 minus n, not n minus 3. Okay, so that's your gradient, and then, you know, you'd get your equation again. It's equal to mx minus 3. So what's f3? F3 is that. So it's looking so big. Times x minus, okay. So what's 3 times that? Times it by -1. So there's that. Okay. So I'm just doing things in my head, guys, to not avoid having to write out a massive bunch of shit. That means that y is equal to mx minus 3m plus f3. I'm not going to expand, but like, you guys know what to do. When you have the gradient, you can just do that. I'm just going to do it now because it's going to take ages. How do you use the fmin/max function on CAS? Is there even a max? Oh shit, wait, let's try. That didn't work. Okay, max and min, you can't, I don't think there's a action for that. Fmin. Oh, okay. Well, from AXDH in the chat, apparently you can find fmin and max, but that doesn't really have anything to do with the questions now. So moving on. Okay, now EIII, find the value of n where 1 is smaller than n is smaller than 3 if there are equal areas between the function f and each line segment. So that's just saying that this area is equal to this area, and find the value of n for which they're equal. So I think it's pretty straightforward. So let me just define my equations. I'll just minus n x minus 3. Jeez, okay. Y is equal to sorry guys, I'm just defining my line right now because I never did that. So Y is equal to that, so I can define, let's just call it z. Why not? Define z of x equal to that. Okay, and I need to define my first line as well. So define, let's just call it L of x is equal to 2e. You get the proper e. 2e to the 1 minus n squared x. So now I have my lines, and then I just need to set up some equations to find a. So it's area, so let me just do the terminals. Oh, you want to set up two definite integrals to find a. So the area of 1, I'm gonna do the, I'll do this area first. So that area is, the graph of f of x is above, so minus L of x dx, and then the terminals are n0 is equal to, now that the line is above, z of x minus f of x dx, and the terminals are 3 and n. So like, I think this question is pretty straightforward. I think the catch is you can't get caught up in, like, you can't get caught up doing this without having defined stuff. So it'll take you ages on the calculator if you don't define things. So I think that's the catch with this question. So now let's solve. Solve for, what the hell am I doing? Solve for 3 0 n f of x minus L of x dx is equal to menu for 3 n 3 z of x minus f of x dx. And remember, you're solving for n. Here you go. Wait, why are they negative? Okay, something's gone wrong again. Give me a sec, guys. I'm trying to figure out what has happened. I think one of the equations for the lines might have been wrong when I was doing it in my head. Okay. But you get the picture. You know, it's pretty straightforward. Letting one area equate to another. It's meant to be, yeah, the m's are referring to the gradient. It's just that I didn't because the gradient is something huge. Like, look, I'll do it right now. F, the gradient is f of 3 minus f of n over 3 minus n. Oh, what the okay. That's the gradient. I didn't want to fucking write all that out. Okay, wait. Y is equal to that times x minus 3 times that plus f of 3. Okay. Hopefully that fixed things. Let's define z of x again. Okay, menu 4 3 n 0 n f of x minus L of x. Oh, I forgot to solve. Just type that in. Equal to menu 4 3 3n minus f of x dx, solve for n. Okay, and now for some reason it's decided to fix itself. So you solve that and you get, what? N is in between 1 and 3. If there are equal areas, okay, I don't know why I keep getting the wrong value, because this method is right. This is what you're meant to do. So let's just leave it, I guess. But you guys can see, like, it's just saying area of this is equal to area of that, and that's pretty straightforward. So moving on. Consider the function this. Okay, I think this is a harder one. Okay. So find the area bounded by the graph of inverse g, the x-axis, and the line x is equal to g. So let's first of all let's figure out what that is. So x is equal to, define g of x to 81 x squared times a minus x over 4a to the 4. Okay, and then g 2a 3 is that. So it wants you to find x is equal to 3, the area bounded by that, g2a on 3, and g negative 1. So let's get our graph of g negative 1. So, and remember, you can get your inverse function really easy on the calculator by just doing this. So I'm replacing x with y, and then I'm just going to solve in terms of y. Okay, and then you end up with a really big thing, which, you know, is pretty bad to work with, and it, like, straight away you can see that this is not the method you want to go with, because it's really complicated and it just won't work out, because, like, what does this even mean? Sine a, like with a g. So this is just the wrong method. So you probably wouldn't want to find the inverse function exactly. So knowing that, you already know that this is going to be a conceptual question. Like, you're going to have to look at symmetry and stuff. So let's just see exactly what these graphs look like. I'm going to do this on decimals because I was doing it earlier, and okay, wait, I'll show you what's wrong with the calculator first of all. So page graph. Go away. Okay, so I'm gonna graph g of x, and I'm gonna let a equal something. Oh, okay. I let a equal 2, so 64. Okay, so that's my graph of g of x, and then let's say I wanted to enter my graph of inverse. Usually on the calculator, I'd go. Okay, so guys, listen to these steps because I think it'll make everything a lot easier, because you don't have to rearrange. You can just go here, graph entry, and then usually there's an option that says relation, and then once you click on relation, you can just enter in the equation, like with x as the subject, instead of having to rearrange for x. But here there's no relation option, but like it's on the computer, but on the normal CAS there is. Like, I literally just did it then. Like, I could select the relation option on the CAS. So if you want to see exactly what I mean, just like go get your own CAS and then just press menu, graph entry / edit, and then select relation. So since there's no relation, it makes it really hard. I'm just going to do this on Desmos. But trust me, you can do the exact same thing on the calculator. So don't stress. So let's just get our equations up. 2 minus x over 64. So there's one. And then the inverse is x is equal to 81 y squared 2 minus y over 64. So there's what the inverse looks like, and then it's asking you, for this question, it's asking you to find the area bounded by this, the x-axis, and the line g2a on 3, and that's 3 on 2. Because it's we worked out that that's 3 over a, and then for our this one here, just to see what they look like, I let a equal 2. So it's asking you to find this area. If you guys can see my cursor right now, it's asking you to find this. Actually, I'll draw them out on one here. So that's a pretty shit graph. So it's asking you to find this area, but you know, it's impossible to find that area because we don't have an equation. So we're going to use symmetry to do it. And think back to like what an inverse function actually is. So like an inverse function, you're swapping the x and y value. So for every x value, it becomes a y value, and vice versa. Every y value becomes an x value. So wouldn't you say that this line, x is equal to 3 over a, corresponds to y is equal to 3 over a on the actual graph? It corresponds to y is equal to 3 over a in on the normal graph, on the normal g of x. So knowing that, like I'll show you guys. Like look. So it wants you to find this area, but then if you take into account that the inverse and the normal graph are just x and y swapped, then you can take finding the area of this to be the same as finding the area of this bounded by the y-axis. Do you guys see? Draw that here. Okay, has that confused anyone? Do you get what I mean, Alice? Anyone else? Okay, I'll just run through my reasoning again. So, the inverse and the actual graph are closely related in that every x value becomes a y value and vice versa. So if I'm trying to find the area bounded by x is equal to 3 over a, then that's the same. Or if I'm trying to find the area bounded by the x-axis and the line x is equal to 3 on a, that's the same as saying on the normal graph, it's the same as the area of y is equal to 3 over a bounded by the y-axis. So you're kind of reversing things. Like, if you guys want to rote learn things, it's just reverse. Like, doing the reverse, right? If I'm finding the area bounded by the x-axis and x is equal to whatever for the inverse, then it's the same as finding the area for the y-axis, or it's the same as finding the area bounded by the y-axis and the line y is equal to whatever on the normal graph. And I'll just show you guys again the shape. Look. If I get rid of these, look. So for the inverse, you're finding this area. Like, it's pretty hard to fucking mark it out, but this one where my cursor is, bounded by the x in that line, and then that looks oddly familiar to this area, and that's because they're the same. So knowing that, let's work this out. So the area bounded by that is the same as the area bounded by the y-axis. So it's the same as this bit. But then, again, like, how do I find that area? Because it's bounded by the y. Well, we can use our rectangles again, right? A rectangle minus, let me just do it here. Okay. We can say that. Zoom into this thing. Okay. So like, if you want to find this area, it's the same as the rectangle of the entire thing subtracted by this. So with that in mind, let's find that rectangle first of all. So that rectangle is the length is the x-intercept here. So, and then with like that's the x-intercept of the line y is equal to 3a. So we can find that by solving for. Where's Bruce yelling? I'm upstairs, so we can't hear Bruce yelling. Okay. Okay, so solve for 3 on a is equal to... What's the point of the inverse, though? Okay, and you're not in year 12, so I'm not going to tell you. Solve 3 on a is equal to g of x. Okay, and... Sorry guys, my microphone keeps stuffing up. Okay, so we worked out... Okay, let me tell you exactly what we worked out. So, I need to draw a better graph. So we figured out that the area of the inverse and whatever is the same as the area bounded by this, the shaded in bit. And right now I'm trying to find the terminal. So I found that x, and I know that's equal to 0. So I found that by letting 3 over a equal to that to find x. So I know that that bit is 2a over 3. So I can say that the area of that is the same as the rectangle. Let me just show you guys exactly. So like if I draw a rectangle, that area is equal to length times width minus the integral of 2a 3 0 f of x dx. That's clear. So I'll just go through the question entirely. So that means, and then the height of the rectangle is 3 on a. So 3 on a times the integral of 2a on 3. Oh shit, sorry. 3 on a times, where's my cursor? Times 2a on 3. That's the area of the rectangle. Minus the integral of 2a on 3, 0 f of x dx. And then this should give you, I remember the answer was 1. So it should give you 1. Let's just check. 3a times 2a on 3. Oh, let's get rid of this. Yep. Minus oh, it was g of x. My bad. That should be a g in my actual thing. And I get 1. Nice. Equals to 1. Questions? What exam is this from? This is from... Oh, wait. I think this is from 2018. Yeah, it's from 2018, question 5. Okay. So, and 2018 was one of the harder ones. Like, notoriously difficult. So we'll go on. Find the value of a for which the graphs of g and g-1 have the same endpoints. Okay. I think this is a straightforward question. It's just interpreting it. So it's saying that, so like your endpoints are here, right? So it's saying that for what value of a will they have the endpoint of x is equal to 2a on 3 and so for what value is a will they have the endpoint of x is equal to a on 3 and y is equal to 3 over a. So I'll just write out the endpoint. So the endpoint should be the point that they want is 2a over 3 and a on 3. Okay, so you have that, and then you sub those values into the inverse equation, right? Because we know that those are the endpoints for the first equation. So to find the same endpoints for the inverse, you just sub them in. But remember, it's reverse. So instead of y is equal to x, I have x equals y. So I sub in it's equal to g. Like for g of y, sub in g. And what that'll look like on the calculator is just solve 2a on 3 is equal to 81 times a, oh, not the scratch pad, times a, oh, times 3 on a, whoops. So right now I'm just subbing in x and y values to solve for a. 3 of a squared times a minus 3 on a. And all of that over 4a to the 4. And I'm solving that for a. And I get these. So we know that a is a positive number. Positive real number, so it's between these two, and then like these two are both answers, but you know VCAL specified that it needs to be in exact values. Well, they didn't say exact value, but they didn't say decimal, so I would just use the exact value one and not the decimal one. Like I don't know why there's a decimal one, but just don't use the decimal one, you know. Okay, so there we go. So we know that 4a is equal to 3 root 2 on 2. They have the same endpoints. And last question for the day. Find the area enclosed by the graphs as g and g-1 when they have the same endpoints. So let's just... I'm sorry my audio keeps cutting out.